your critical value. Find your cutoff using your inverse norm. We've done this all year long. Better? Well, they shut off two of the lights. It usually helps if the glare off. Okay. Left tail test, 0.09. That is the area to the left. Look it up. That's your critical value. All you had to do was give me a sketch, critical value on the first view. The sketches are the most important part of this whole thing because it tells you where your tail is, it tells you where your cutoff is, and it's a good, they just wanted the critical value, but it's a good thing to constantly put this on here. This is your reject O, HO, this is your fail to reject HO. So it's very, very visual. And this is your reject HO. So when we do our own z-score test, we'll know where it falls. Can everybody do this part? Okay? All we're doing is looking at it from a different point of view. You did your areas before with your p-val, your level of significance. Now we flipped both of them to the z-scores. Two-tail test, just like we did before, it has to share 0.02. So when your confidence interval, we did your 1 minus that because it's sat in the middle. This is the two tails on the end. They're sharing. So divide it by 2 and find it, a negative and a positive. Again, label it, and then you had to tell where these scores fit for this one. This was a good one. They gave you the graph. And then they gave you different z-scores. These are your critical values. This determines where this piece is, right here. That determines your cutoff. So now, if they give you a score of 1.631, remember this is a number line. Put the 0 in the middle, it's going to help you figure out where you're going. This is before 1.645. You're in the fail to reject H0. This is 1.73, it pushes us past there. You're in the reject H0. These are your decisions that you make. These are decisions. You're in the negative 1.464. It's very close to this, but it's right before it. You're in the fail to reject H0. And you're in 1.6, negative 1.655. Again, very close, but you're to the left of it. In the reject H0. It works like a number line. Good? All right, stop me if you have any questions. Okay, 28. Again, same thing. Your reject zone now is very small. It's a little smaller, which that means you have a smaller level of significance. You want it to be more confident, less room for error. It works the same way as your confidence does. That's completely the opposite. If you want to be 99% confident, you're going to allow a 1% chance of error. So you're going to share this guy, and you're going to reject if it falls on either tail. So again, 5575, if it helps you, do this. Line it up like this so that you can see it, 557. So here it is. You can tell right here, oh, that's before it. I know it goes before it. Just line them up. It's in your fail to reject H0. 27, this guy's a 7 over here. Now, to the left, 2755. 2585, oh, it's bigger than that one, in the reject. Reject H0. And then this one was right before your left cutoff. Good? I like the reject regions just because I think when you can see it, it makes a little bit more sense. And the graphs are so important here. So let's follow one through. A company that makes cola drinks states that the mean caffeine content of 12 ounce, we don't need the 12, is equal to 40 milligrams. There's your statement. That's the claim. And if you don't catch the claim there, you'll catch it here at the very end. can you reject the company's claim? Reject has to be an HO and the company. So go back to see what the company said. That's another easy way to find your claim. Sometimes they say it first, sometimes they say it in the middle, sometimes they say it last. Usually the reject and the support word will help you figure out which one is which. So we have the claim, the opposite, the complement, the HA. HA says two tails. Find your critical value, use your .01, share it, and find your critical values. Do your z-test. Your z-test comes from your sample. Use your sample. You can put it in stATS. Use the z-test. God bless you. Use the z-test and get the z-score that comes out of that one. It falls in the fail to reject H0. Now, if your claim is H0, this guy, and you fail to reject it, that means you take it. But the way we word this is, there is not enough evidence to reject the claim that the mean caffeine content is 40 milligrams. Make sure you give me the claim. That's your last statement when you do this. Good. $42. Says you work for a national health organization. You are asked to monitor the amount of sodium in a certain brand of cereal. And look, they gave you all your test stuff first. Now, here, they gave you what you're testing. Can you conclude that the mean is less than 230 milligrams of sodium? So that's your claim. Okay, you're testing this claim. That's why you did all your sample information. So you take your sample, find your z-score, use your level of significance, find your cutoff value. This is your reject H0. We should label this. And this is your fail to reject H0. Okay, remember, your errors are small. It's got to be the smaller part of that graph. It's got to be the shaded in part. It can't be the big one because you're not going to have a big error. So if your claim is your HA, and that's the one that follows the tail, and your decision is reject H0, fail to reject H0, here's your claim, here's your fail to reject H0, which means we had to go with the H0 one, even though that wasn't part of our statement, we have to go with this guy. So there's not enough evidence to support the claim that it was less than 230 milligrams, that the mean was less than 230 milligrams. Follow your charts. For 43, I gave you one that you had to put in your calculator. Put it in, and I would just put it in, do your one-var stat, find your sample mean and your sample standard deviation right off your calculator. You're using a sample, so it's not your population standard deviation, it's your sample standard deviation. This is your reject H0, this is your fail to reject H0. Here's the claim right here. Can you support? Support says HA. The scientists estimate. Well, the scientists estimated that the mean nitrogen dioxide level was greater than. There's his claim. HA and greater than. You have a right tail test. It follows your HA all the time. Find your cutoff at 0.06 and do your z-score test. You see a pattern through this? Are you comfortable using the reject regions? I think the reject regions, I think the p-val is easier because your calculator gives you a p-val and then you just test against your level of significance. But I think this one actually makes more sense because you physically see where it falls. Your p-val, if you don't test the p-val exactly the right way and follow the, if it's less than or equal to, reject H0, you're going to get the p-value mixed up. This one, I think, is a more visual approach. We can fit it into your sketch, and you can kind of see where your graph goes, where it takes you. And the last one, you want to say if it's at least, think money in your pocket. If you have at least $10, you have $10 or more. So mean is greater than or equal to 10,000 hours. The complement is less than or equal to. Again, this is your reject HO. This is your fail to reject HO. Okay. State your claim. Here's your claim. You know it says reject. It's got to have an equal sign in it. And it did, greater than or equal to. There was the manufacturer's claim. Usually, and I hope you see a pattern here, if the manufacturer makes a statement and you're challenging that, you want to reject his claim. If the manufacturer makes a statement and you're agreeing with that, you want to support his claim. So that's why we play with the words, like in the wording a little bit, to see which one do we make an HA, which one do we make an HO. It depends if you want to reject or support their claims. Questions? Everybody has this down. Good. Okay, now samples. And your T used small samples with degrees of freedom. Same thing it did with your confidence interval. So it just brings us to a smaller sampling set, and we use your degrees of freedom. So therefore, the only big difference is your critical value. Your critical value, we're going to be using your table 5 to get your T critical value. And we have an inverse T that might help do that a little bit there. So that one might help a little bit using your inverse T in your calculator. Basically, it's going to work the same way. Your guidelines, you find your level of significance, and here's the big difference, your degrees of freedom. Degrees of freedom, you're going to look in table 5, okay? If it's a left tail test, and the nice part about table 5, and I don't think they give you a section of it, but if you turn to table 5 on page A18, in the little blue margin in the back, you're going to see it says a 1-tail and a 2-tail. So you don't have to split anything up. If it's a 1-tail, you follow your 1-tail. Look at page A18 on your blue binder. You see on the top, you see confidence interval, the confidence level. We're not doing that one. That was your level of confidence. Then it's either going to say a 1-tail or a 2-tail. Now, if you take the left tail, obviously it's for the left side of your graph. You're going to find your value and you're going to make it negative. All your values in there are positive. If it's a right tail, you're going to go to your 1-tail and you're going to make this a positive value. If it's a 2-tail, the nice part about it is you go to your 2 tails and one's a negative and one's a positive. You don't have to divide anything in 2. All you have to do is find your degrees of freedom and your level of significance.
So is it more often going to be a right tail test than a left tail?
No, there's no more often, but it's your nice. The nice part about it is your table doesn't make you differentiate and have to divide anything by 2. It just makes it a little bit easier. So we're going to work on finding your critical values. The nice part about your t-test, it works the same way as your z-test does in your calculator. And when you do stATS, z-test, your t is right below it. Your t-test is right there, right below it. It works the same way as your other one does. So let's find a critical value or 2. That's the only real difference. Everything else works the same. Your claims work the same. Everything works the same. Keep your table 5 handy. So you want to find the critical value for a left tail test. Here's your left tail. This still says reject H0, and this says fail to reject H0. You want this. It is now a T sub O. This is your critical value. This is your cutoff. So, what's my degrees of freedom? If my sample size is 20, what's my degrees of freedom?
20.
Oh, sorry, my sample size is 21. My degrees of freedom is 20. Now, go in your chart, page 818. Take your degrees of freedom 20, find the one tail, and find the 0.05, and come down and tell me where it's at. What the score is. What do you find? 1.725. Thank you. So you look this up. Now, because it's on the left-hand side, it's less than 0, you just stick a negative sign out here. Okay. Follow across the top. Take a one tail, find your 0.05, find your degrees of freedom. Before we found your level of confidence on the tippy top. Now you're in the second one or the third one. So can everybody do that? Okay. Find me a critical value for a left tail test of a level of significance of 0.01 and n of 14. Find me a cutoff for that. Find me your cutoff for that one. Here's your table. 2.650, so which one should this be? Negative 2.650. Make sure you do your degrees of freedom. The nice part about that chart is it says degrees of freedom on your left-hand side. So even if you're looking at your sample, look at your chart, because it says degrees of freedom. Easy, right? This guy's a little easier than your z-score is. Okay, find a critical value for a right tail test. Okay, here's your right tail. This is your reject H0. This is your fail to reject H0. Okay, I want your critical value. What's my degrees of freedom? 16. So find me your cutoff for this. .583. Is it positive or negative? Positive. It's on the right-hand side. It's positive. Okay, makes sense? T-score is nice. And the last one is the two-tail test. Okay, I've got two tails to this guy. Here's your reject. Here's a reject. Here's a fail to reject. I want a negative one and I want a positive one. What's your degrees of freedom on this? 25. So what are you going to look up in your table? Two tails. Do you have to divide this in half? No. You don't even have to divide it in half. It does it for you. So find me your cutoff point. Good. So if I use this, which one is negative? The left. Good? You okay with the cutoffs? Alright, so this guy's kind of nice. Makes it easier. Now, your test statistic is the same as your z-score. It's just your t-score. Now, the reason we use a t is because the sample size is less than 30, or we don't know the population standard deviation. So hence you see the sample standard deviation in here. Same exact thing as we used before. However, make sure when you do n, that you do n, not the n minus 1. You want the sample size, not the degrees of freedom. Okay, and again, your book has, your calculator has a t-test in it. It's number 2, t-test. It works the exact same as your z, and it returns the same thing. As a matter of fact, if you're looking for a eval, we're not, oh, that's the chi-square. Okay, we'd be able to find a eval. This one's just probably going to do the reject. So here's your guidelines. Actually, if you're looking for a p-val, I think only your calculator is going to give you a p-val. We have no way to take it off the table. We don't have a table like your table 4 does. Table 5 only gives us your critical value. So if you want a p-val, you'll definitely have to use your calculator. All right, so the guidelines is we're going to state your claim again, same thing, your level of significance. Here's the difference right here. And we use a tape. We use your critical values to do a cutoff, and we make a decision. Same exact way. Everything pretty much stays the same. Your formula stays the same. It's really kind of no difference to you because you're still just given a standard deviation. So let's just try one, and then we'll call it a day, and tomorrow we can finish this up. Wednesday we can finish this up. Okay, example 4. I'm on page 366, 367. A used car dealer says that the mean price of his Ford blah 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 is at least $18,800. You suspect this claim is incorrect. You suspect this claim, so therefore this is his claim. He's the dealer, so you want to prove him false here. Not false, but you want to kind of reject him, and find that a random sample of 14, here's your sample information, here's your sample mean. Always pull out your sample as soon as you read it. There's your sample standard deviation. Is there enough evidence to reject, oh, this had to be an HO, the dealer's claim, and here's my level of significance. So here's your claim right here. Your claim says the mean is at least. How do I say at least? Good. Greater than or equal to. Okay. This is HO. Oh, yes. And it makes sense because it said the word reject. So it makes sense. Your HA is its complement. So what tail test is this? Yes.
Wouldn't the claim be like, you is less than or equal to? Or wait, no. Oh, never mind,
Yeah, think money in your pocket.
I got it.
Yeah. Okay, so we've got a left tail test. We're going by this side. So this is the reject H0. This is the fail to reject H0. We need your cutoff. How do we find your cutoff? Degrees of freedom. So if my sample size is 14, my degrees of freedom is 13. Look in your table, one tail test, 0.05, degrees of freedom 13. What's your cutoff? 1.771. Good, and because it's on the left, good. Okay, then we're going to test your mean, your sample mean, minus this, and it should be negative, right? Because our test is on the left-hand side. Over your standard deviation divided by the square root of 14. And it should be negative, right? Because your test is there. Good, thank you. So where does that fall? Reject. So our decision is reject H0. Really any major difference from the last one? Okay. Wednesday, guys, we're